Now let's continue our journey to developing the knowledge on the different rules of differentiation. So next rule would be the product rule. So we say that d dx of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x, where f and g are differentiable functions and x. Okay, so now let's prove this rule and see a couple of examples. So to find the derivative of f of x times g of x, we will be using again the limit definition. So we have limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x divided by h. So now the idea here is you need to add and subtract a term to this limit. So what I will have here is limit as h goes to 0 of f of x plus h times g of x plus h. So now in between here, between f of x plus h times g of x plus h and f of x times g of x, I would want to add and subtract the term f of x times g of x plus h. Okay, so I'm adding that. Let me actually put that in a different color. I'm subtracting and adding that f of x g times g of x plus h minus f of x g of x divided by h. Now, what I'm gonna do is I am going to combine these two terms together and these last two terms together as well. So from the first one, as you can see, I can factor out g of x plus h. So I will have limit as h approaches 0 of g of x plus h times f of x plus h minus f of x, and then plus, and in the second group, I will factor out the common f of x times g of x plus h minus g of x. That is all divided by h. Now what I'm going to do is I'm going to separate these two fractions and apply limit to each of them separately. So I will have limit as h approaches 0 of g of x plus h times f of x plus h minus f of x over h, and then plus limit as h goes to 0 of f of x times g of x plus h minus g of x over h. Now let's look at this first limit separately, and if h goes to 0, this will be just equal, this will approach just g of x, right? And if h approaches 0, this portion will approach to f prime of x, right? So we can write it as g of x, and h will be approaching 0, right, times f prime of x plus. Now, if we look at the second term separately, this one has nothing to do with h, so that's going to be just f of x times, and now this portion, as h goes to 0, will be approaching g prime of x. And this is where we get this definition from, or we can change the location. We can change the position of this g and f, and we have f prime of x times g of x plus f of x times g prime of x, and we proved this product rule. Now let's look at the example. Find the derivative of 3x times e to the x. Okay, so we will be treating 3x as our f of x and e to the x as our g of x. Remember that the rule is the derivative d dx of f times g is equal to f prime g plus f times g prime. So the derivative of this function will be, now first we need to take the derivative of f. So the derivative of 3x is going to be just 3 times x to the 0th power. So we just write as 3 times g. So we'll just need to rewrite g without changing anything. Now plus, now we need to rewrite f without changing anything and times the derivative of g. So f is 3x times the derivative of g, which is the derivative of e to the x, is again e to the x, because this is the derivative, it doesn't change. So this is what we will have for the derivative of 3x times e to the x. Now let's look at the next example, d dx of 2x squared minus 1 times x plus 3. Again, you can use the power rule, but before that you'll need to FOIL this function. But you can actually use the product rule right away, and you will have, so this is your gf and this is your g. So again, by the rule, we have the derivative of 2x squared is going to be 4x, and then minus 1 is 0, so we don't write that. So this is the derivative of f times just g, which is x plus 3. So this is just g, and then plus, now we rewrite the f and we take the derivative of g. So when we rewrite f, we have 2x squared minus 1, and g, the derivative of g will be derivative of x is 1 and derivative of 3 is 0, so we have just times 1. So if we simplify it, we have 4x times x plus 3 plus 2x squared minus 1 as it is. Okay, so this is how we apply our product rule. Thank you.